arithmetic sequences. So first off, to start with some definitions, an arithmetic sequence is a number sequence formed by adding or subtracting a fixed number, so the same number each time, or to a previous term to find the next term. So you're doing the same pattern every single time. You're either adding or you're subtracting the same number. And whatever that number is that you're adding or subtracting each time is called the common difference. So you'll see throughout this, they use the letter D to distinguish what a common difference is, whatever that number is that you're adding or subtracting each time. You'll also see throughout this chapter or this section, this notation right here. That is the way to say it is A sub n. So when we're talking about that, you would say A sub n. Or if you look below, it says A sub 3 with that big A and that little 3. And that means the third term of the sequence. Or A with a little 10 would be, say, A sub 10, and that means the 10th term of your sequence. Then we're going to be writing two different formulas when we're writing arithmetic sequences. So we could either write a recursive formula, and the equation for that is right here. And in that equation, we would write our A sub 1, and we would write whatever our equation is, A sub n equals A sub n minus 1, just like that, plus the D. So whatever is adding or subtracting, we would put on the end. So if it was adding 4, we would put plus 4. If it was subtracting 2, we would put minus 2. Then with the explicit formula, we would write A sub n, just like that, and we would write A1, which means our first term of our sequence, whatever that is. And then we would put n minus 1 in parentheses, just like that, and then that common difference on the outside. And we will simplify that equation. So let's do some examples that use all of this in our notes. So our first example says, is the ordered list 26, 39, 52, 65, 78 an arithmetic sequence? So let's first figure out which term is which. So A sub 1 is our first term of our sequence. So our first term of our sequence is 26. A sub 2 is our second term, and in our sequence, that number is 39. A sub 3 is our third term, which is 52. And then it keeps going. A sub 4 is our fourth term, which is 65. And A sub 5 is our fifth term, which is 78. So we're looking for what is the pattern, either adding or subtracting the same number. So if I look, I can see that they went from 26 to 39. When they did that, they added 13. And you can double check that in your calculator if you need to. 26 plus 13 is 39. Now, if this is an arithmetic sequence, it should continue to add 13. Let's double check that that works. Is 39 plus 13 52? It is. So again, we added 13. Let's double check that it works for the next couple numbers in our sequence. So 52 plus 13 is 65. So it's adding 13 again. can state that our common difference, or the D, is 13. Positive 13, since it was adding 13. All right, let's look at our next example. Example 2 on the next page. It says, given the following, A1 equals 39 and D equals negative 5, find the recursive rule. Then find what A4 is, or A sub 4, excuse me. So first off, we need to write our recursive rule. When you write the recursive, you always have to state what your A1 is. So A1, they told us, was 39. Then in our equation for recursive, I'll write your formula first, and we're going to fill in what we know. So when you're writing recursive, the only thing that you're changing is what the D in your equation is. So they told us that our D was negative 5. So I'm going to put minus 5. So this tells me that from my previous sequence number, I'm subtracting 5 each time. Okay, now I need to find what A sub 4 is. So in order to do this with a recursive rule, you have to figure out each number in your sequence. So we found already that A sub 1 was 39. Using my equation, I want to find what A sub 2 is. So anywhere there's a N, I'm going to put a 2. So A sub 2 minus 1 minus 5. Well, I know that 2 minus 1 would be 1 minus 5. So I can see that I would take A sub 1, or my first term, and subtract 5. So that would be taking 39 and subtracting 5, which would give me 34. Now I need to keep going because I have to get to A sub 4. So I'm going to do this again with my next term. I'm going to find what A sub 3 would be. So anywhere there's a N, I'm going to put a 3. So 3 minus 1 minus 5. So right here I know that that is A sub 2. So I'm going to take that A sub 2 that I just found of 34, and I want to take off 5. So notice I'm doing that previous term each time minus 5, which would give me 29. So my third term is 29. All right, last one, we are finding that A sub 4. So anywhere there's an N, I'm going to put a 4. So I know that 4 minus 1 is 3. So I want to do my third term, which we found as 29. And I want to subtract 4, which would give me my fourth term is 24. So the nice thing about recursive is it really shows you the pattern that's happening throughout your equation. So we're going to do the same example again, but we're going to write the explicit formula this time. So I still have an A1 of 39 and a D of negative 5. So I want to write the explicit formula. And I'm going to write the equation up here for you so we can fill in the blanks. They told us that our A1 was 39, so I'm going to fill that into my equation. And they told us that the D was negative 5. Now, this is times negative 5. So I want to simplify this as much as I can. So I'm going to distribute this negative 5 into my parentheses. So I would get 39 is not changing. Negative 5 times n would give me negative 5n. And negative 5 times negative 1 would give me positive 5. Then I see that I have some like terms, can go together, giving me negative 5n plus 44. You must simplify that equation every single time. Distribute and combine your like terms. So now that I have this equation, I can use this equation to find any term in my sequence, which is very nice since they're asking in the next step for the 52nd term, which means that in my equation, I'm going to plug in n as 52. So I want to find a sub 52. So I'm going to plug in n is 52. And I'm going to solve this. So I can first figure out what is negative 5 times 52. And that's negative 260. And then if I add those together, negative 260 plus 44 is negative 216. All right, let's look at our last example on the next page. So this one they're representing with cubes or blocks. So in the first term, there is 1, 2, 3, 4, 5 blocks. So our A1 is 5. And then I can see that in each one, they're adding 4 blocks. So that's our pattern. Each time, they're adding 4, which tells me that my common difference is positive 4. So for my recursive, I have to write my equation. Every time I write recursive, I have to say what my A1 was, and that was positive 5. And then I have to write my equation. So A sub n is A sub n minus 1 plus my common difference, which was positive 4. Then I have to write my explicit. So it's similar. We use the same things, but we have to write the different equation. So A sub n equals our A1 plus n minus 1 times d. So I'm going to plug in what I know. I know that A1 was 5, and our common difference was 4. So I'm going to multiply by 4. We need to simplify this as much as we can, so I'm going to distribute that 4. So that would be 4 times n would give me 4n, and 4 times negative 1 would give me negative 4. Then I have 5 minus 4 that I can combine together, which gives me my equation of 4n plus 1. So here are my 2 different equations, recursive and explicit. Now, you can use either one of these equations to find the terms in your sequence. I personally like to use explicit better. It's much easier once you find that equation to use it to find different terms within your sequence. So I'm going to use this explicit equation to find what they're asking me to find below. So I'm going to find what A sub 6 is first, using this equation. So anywhere there is an n, I am going to plug a 6. So that means I would have 4 times 6 plus 1, which would give me A sub 6 equals 25, because 4 times 6 would be 24. 24 plus 1 would give me 25. So the 6th term in the sequence, if I kept going, it would have 25 blocks. Let's do it again with the 45th term. So anywhere there's an n, I'm going to put a 45. So I'm going to do this in my calculator, 4 times 45 gives me 180. And 180 plus 1 would be 181. So if I kept going, adding 4 blocks each time, and I got to the 45th term, it would have 180